correction factor. This slide talks about the correction factor for art of contact. The reason so is we have two different sizes of pulley, and the art of contact correction factor will consider the deficiency of the belt driven process. So refer to table A1-10, which is at page A1-10. Correction factor for art of contact. If you look at the table here, on the left column, there will be a D minus small d over CA, which actually your big D is your large pitch circle diameter and your small d is a small pitch circle diameter. 240 minus 120. Right, let's write it down. Okay, this one will be actually here, so I don't need to write it down. Okay, it's 240 minus 120. Okay, this is the pitch diameter we use. It's always there. All right. And what is the CA? CA is actually the actual center distance you calculated, which is 743.33. So you realize that these three factors will affect your angle of the belt at out of contact. So when you punch in the numbers, you will get 0.16. Okay, 0.16. So you following the column downwards, 0.16 fall in between 0.1 and 0.2, right? So if you were to be concise, you will actually need to interpolate to get a correction factor. But then again, unless it is the exact value, okay, it's referring to as 0.1 exactly or 0.2. If not, otherwise, we always use the smaller correction factor. Even if it's 0.11, okay, example, the calculation, after you calculated, you get a 0.11. We will advise you to use the correction factor of 0.97. Always use the lower or smaller correction factor. Reason so is this will give you a better, safer side of calculation, all right, which we will explain further. You realize that when will you achieve 0.00, you will actually be your two pulley having the same size. Okay, 240 minus 240. Okay, you will get a 0 because 0 divided by any CA is 0. So that's why the correction factor is 1. All right, so we always go for lower correction factor. If it's a example, you get a 0.205, we'll use 0.96, right? Unless you get exact 0.20, then you use 0.97. Okay, so that is what you need to remember for. The next table you need to refer to will be A1-11, correction factor for pitch length, page A1-11. If you are at that page now, okay, give you a few second moment. Alright, so when you're at A1-11, you will see a few columns where there's a standard length design, numbers for you, and cross section that referring to the belt section you want to use A, B, C, D. So in this case, our example here, we have selected section B. So if you remember, I keep emphasizing when you determine your belt pitch length, you get a B81. This is the number that I say is very important. You're supposed to take note of. This is the time where you will use this B81. So your B referring to here, I'm interested in cross section B. And do you see 81? That is the one that you obtain 81. All right, so your belt length correction factor is referring to the belt section number B81. Okay, so you go to B81 and your correction factor is 0.98. 0.98. Okay, 0.98. So in that case, your belt length CF. So how do we determine the number of belts? Okay, we will have three calculations because we have three options to show you what are differences. So the correction power rating per belt. So you want to input the correction factor. So 0.98 times 0.97. One is the belt length, one is the arc of contact. multiplied by 4.52. This 4.52 is your power rating per belt. So this is option 1. Okay, power rating per belt option 1, which we did earlier, the earlier video. All right, we determined that 4.52 horsepower using 115 mm pitch diameter. So you multiply the correction factor, you realize that my power rating per belt horsepower reduced 4.3 instead of 4.52. Reason so is very simple. Using 4.3, okay, we have to determine number of belts, okay, the desired power divided by the corrected power rating per belt. So 19.11 is our design power. So if divide by 4.3, you will get 4.4. So if you don't use the correction factor, you use a 4.52 directly. Actually, in fact, it gives you a lower number of belt needed. So on the safe side of calculation, right, we always have the correction factor consider deficiency of that, because over a period of time, or usage of the belts, right, the belt itself will actually elongated and the deficiency will start to show. So this is option 1. We're using 115 mm pitch diameter. Okay, so the data here we use and we'll get 4.4 and you round it off to 5 belts. So that means this example, you will use a section B 81 and you need to order 5 belts, right? 4.4. You can't get a 4.4 belt. So let's move on to the next slide. Talking about option 2, repeating calculation. So option 2 is using 125 mm pitch diameter data. The correction factor remains the same because of your pitch diameter and the belt length is the same. So 0.98 multiplied by 0.97 and only the horsepower rating per belt slightly different. So option 2 using 125 data, we have a higher horsepower per belt 5.44 and you multiply the correction factors will give you 5.2. So number of belts is design power divided by corrected power rating per belt. So 19.11 divided by 5.2 will actually give you 3.675. So 3.675 you round off, you get 4. This option will offer you 4 section B belts, right? So option 1's calculation told you need 5 belts. Option 2, 4 belts. Okay. So the next one will be interpolation. All right. So the third option is actually interpolation between 115 and 125 to obtain a 120 mm pitch diameter data. So the power rating per belt for 120, in this case will be 4.27 plus 0.71 will be 4.98. So you use the same correction factors again, you get 4.73 horsepower. So using this 4.73 horsepower, the design power divided by that, 19.11 divided by 4.73, you will get 4.04. And option 3 will tell you that you will need 5 section B belts. Is it the same as option 1? Yes, it's the same. So no matter what option you have, as long as you have 4.0 something, 01 to 04 or 4.1, anything above 4, unless it's exact number of 4, all right? If not, you always round off to 5, the next higher number. Reason so is this is a safety factor consideration. Okay, your systems require 4 over belts to run the transfer the power. So if you use 4 instead of 4.04, your failure mode or your belt failure will come earlier than needed. So your maintenance cycle will be shorter. So now most of the time we recommend 5 belts, and this is also to consider possible error in your calculation. So that's why we recommend you to use 115 pitch diameter data instead of 125 because offer you more belt option. All right. So option 1 will be what we'll be using. Unless the diameter is exactly the same, if not, we will use the lower data to give you a lower horsepower rating per belt. Okay, and that will give you a better safety margin when you do a calculation of number of belts. So always go for the safe side. All right, we have concluded example 1 calculations. It's break into various segments for your ease of understanding and refer to revisit the video easier rather than one whole video. You need to go and look for the particular steps. So of course, the best is you will refer to the PDF slides to run through your example. My advice to you is use this example as a guide. Work it out without the reference. I mean, you work with the example on a fresh page using the appendix to find, and if you are able to achieve that without any reference of working steps or videos, then you may want to work towards your tutorial and to further enhance your appendix usage. All right, the next slides or videos we will summarize the steps of this calculation needed.